All right, the next lesson is to talk about hydroelectric power, and we're talking about the power that we get from water in rivers and dams. So how does it work? All right, it depends on building dams, and dams are built in very specific locations. Like you need steep river valleys. All right, and you can't just put up a dam wherever you like. All right, you need those very steep river valleys. The way these things work is to literally pile up water as high as possible behind a dam. All right, so the higher you build up this water behind a dam, the better. That's the key here, is to pile up water as high as possible. And then what we're going to do is we're going to allow an opening here. All right, and that opening is called the penstock. And the opening allows water to flow at a high level of speed down this penstock, down this opening, and it turns a turbine, which is hooked up to a generator, and that turns the energy into electricity, which can then go out onto the grid. All right, so the rest of the water can then continue on downstream, and there you go. So the goal is to get as much water through the penstock as possible, and it will then turn the turbine, which is hooked up to a generator, which generates electricity. So there's no emissions. All right, all we're doing is building a dam in a steep river valley and allowing the kinetic energy of the water to flow through our turbine to generate electricity. Pretty simple. All right, but that's the key, is to get as much water through as possible. We want tremendous water pressure going through these things. So we have to think about it in regards to energy transformations. So we look at kinetic energy, which is 1/2 mass times volume squared. All right, and then we need to look at potential energy, which is mass times the gravitational constant times height. All right, so the goal is to get as much kinetic energy as possible. So first, we have to take potential energy, all right, and we're going to try and convert that into kinetic energy, which can then turn a turbine, which can generate electricity. All right, so how can we make a large amount of energy in a dam? It's all about the potential energy. Okay, so the potential energy, it's all based on the mass times gravitational constant times the height. Okay, so this is why we build dams the way we do. To get enough kinetic energy to get electricity, you need the max amount of potential energy. All right, the potential energy comes from the mass. So to get the most mass of water, you build a giant dam that holds lots of water behind it, and then you raise that water as high as you possibly can. All right, so now we've maximized the amount of potential energy in the system, and then we allow it to flow down the penstock at a high rate of speed to generate as much electricity as possible. So the goal of the dam is to create the max amount of potential energy you can in the water. All right, so that's why we have such big, giant dams in these steep river valleys to hold a massive amount of water behind a really high dam. And that's how it works, through converting energy from potential energy behind the dam to moving water, all right, and kinetic energy that can turn a turbine that's hooked up to a generator to create electricity. All right, let's take a look at some dams that are out there. Here's the Hoover Dam. Today, these dams are very expensive. There's a high upfront cost when it comes to building dams. However, they create a substantial amount of energy. And after the initial construction phase, all right, there's very little operating costs for these things. So even though they have a high initial cost, they have low operating and maintenance costs afterwards, and they generate a tremendous amount of energy. Right, and here's a picture of the turbine. Okay, the water is flowing through the turbine, which goes through a pipe in the middle. It spins the turbine, which is connected to a generator, which generates the electricity. All right, so this is inside the Hoover Dam. And you can see how many turbines are there in a row. All right, here's another dam. This one happens to be the largest dam in the world. This is the Three Gorges Dam in China. All right, it's the largest hydroelectric power plant on the planet. All right, just tremendous, massive amount of water. All right, it's the largest concrete structure in the world, and it's pretty hard to get a sense of scale here. The dam itself is over 600 feet tall, but I'll try and help you here. If you look at these jets here in the top right, if you look at these jets emitting water out of the dam itself, that's the same picture as this. Okay, that's the amount of water coming through this thing. All right, just huge structure. All right, now let's take a look at this map here. And what we're looking at is where all the dams are located in the United States. All right, these are all hydroelectric plants. We've pretty much taken up all the possible locations that we could build a plant or a dam. All right, everywhere has been dammed that could possibly be dammed. Remember, these have to be in a specific location in a steep river valley, so you can't really just put up a dam wherever you want. So you can tell that the United States has a storied history with hydroelectric dams, and most of these were built in the 1930s and 40s during the Works Progress administration. All right, so a lot of these are starting to crumble or being decommissioned because of they need upgrades or they're just falling apart at this point. So the potential for hydro to continue to grow really isn't there, all right, to meet our needs in the future. We've already maximized hydroelectricity at this point in the United States of America. Many developing countries are moving in this direction because they're where we were 100 years ago. All right, they have growing energy needs. All right, this is a sustainable method of getting electricity, so a lot of countries around the world are moving towards hydroelectricity. However, the potential for hydro in our country just really isn't there. It's already been exhausted. All right, but if we look at a little bit smaller of an operation, there's something called run-of-the-river hydroelectricity. And what we're talking about here is where there's either a smaller amount of water storage behind a dam or none at all. Okay, this is ideal for streams or rivers that are smaller but have a minimum dry weather flow, or those that are regulated by much larger dams and so forth. The advantage of a run-of-the-river hydroelectric plant is that there's less of a change to the natural habitat. There's a bunch of advantages and disadvantages to these smaller systems, but here's what one might look like. All right, you have a river where you're going to take water upstream somewhere and divert it down a man-made penstock or a pipeline, and then turn a turbine here in a small generator plant or a powerhouse, all right, and then return the water back to the stream or river. Very much less impact to the environment and habitat, all right, but it generates much less energy in a run-of-the-river project. All right, so when it comes to large hydroelectric dams, all right, there's pros and cons. Okay, so let's weigh those very quickly because that's the most important part. All right, the pros is that they generate tremendous amounts of electricity. Okay, they have low operating costs. Okay, it's a clean energy source. All right, there's no pollution. All right, it's completely green, completely renewable. All right, it controls flooding. Okay, it supplies water in case of a drought. These things can be shut down immediately. All right, unlike nuclear plants or some other forms of generating electricity, these things can be turned off immediately in the event that they have to be. So there's very few issues. It allows for recreational activities. All right, behind this dam you see here is a great place to fish and boat and jet ski and camp and so forth. All right, so lots of pros when it comes to hydroelectricity. Few of the major disadvantages, there's a lot of disruption to habitat. Okay, and this picture shows it very well. Where this dam was built, you had a river come through here in this very narrow river valley. But now that the dam is here, you've flooded a much larger area. All right, you've taken away lots of habitat space, and you've also taken away the ability of fish that may have to get up the river. The salmon make a run upriver to their spawning grounds. So if you place a dam in the way, there's no way for that salmon to get upriver, and that becomes a big problem with that particular species. All right, there's high initial cost. All right, these things are very, very expensive to build, although they have low operating costs. All right, drought could affect performance. All right, and the last con then is that there are very few, if any, viable locations left along our rivers. So we have to turn to more expensive alternatives. All right, so hopefully that gives you a sense of the advantages and disadvantages of hydroelectricity in regards to building dams here in the United States. All right, but there is another option, and what we can do with hydroelectricity is harness the energy from tidal environments. All right, the only thing is that this is super expensive, and it will not be utilized until we are desperate and willing to spend huge amounts of money to harness this energy. However, it's promising. All right, especially in places like bays and coves. Right, there's all kinds of designs for these things. Really, they haven't been utilized yet because of the cost. But just like a hydroelectric dam, that's what we want to do. So we'll go into a bay or a cove, and we'll create a dam underneath the water. So at low tide, the water will go on the one side, and then at high tide, it will move through our dam and turn that potential energy into kinetic energy, hook it up to a turbine, and generate electricity in that way. So there's all kinds of designs for these things. Like I said, it's just too expensive at this point. We're not desperate enough to be willing to spend these huge amounts of money. However, there would be advantages and disadvantages, just like hydroelectric dams. So we'll have to wait and see if this type of hydroelectricity takes shape in the future ahead. Alright, so I'll leave you with a list of the pros and cons, and which can allow you to weigh hydroelectricity as a potential source going into the future. And as I leave you here, there's a picture in the bottom right here of what's called a fish ladder. Alright, and this is an answer to the problem of disrupting the salmon life cycle. All right, those salmon need to get around the hydro dam to reach its spawning grounds upriver. So fish ladders are a way for fish to navigate around the dam and get back to their spawning grounds. So hopefully the next time you bask in a shower of falling water, all this will come back to you, and you can review some of these concepts about hydroelectricity, how it's generated, and the advantages and disadvantages of this type of energy.